You take a motorcycle and mix it with a scooter. That's what you did.
Actually, mine is kind of an electric scooter. Right, yeah. It's got 20-inch tires that are about that wide.
Yeah.
Well, we're live now, so I guess. I will tell you one story of my youth. I was about 14. I had a motor scooter, or it wasn't a scooter, it was a motor bike, kind of like a moped, but a different brand and a little more powerful. One day, the road construction crew had a nice big pile of asphalt right in the middle of the road. And here I have these envisions of Evel Knievel going up, catching air, you know. So here I am, I'm going about 30 probably. Run into this thing and my front wheel sticks in the soft asphalt. And the bike goes kadunk with me right on my head in the asphalt.
See, nowadays, that's what you call an endo.
Yeah. Okay, well, we better get started. Now, we've covered a variety of skills and a variety of methods of solving quadratic equations, okay? We talked about discriminants and how they can predict what kind of values that you'll have. What we're going to do for a little bit, and this is kind of an extension beyond what they're calling for in the official lesson plan, but I think it would probably be time well spent, hopefully, is we're going to do just a little bit of general review on different kinds of quadratics, just kind of as a wrap everything up. Okay, now, obviously, the simplest way to solve a quadratic is if you can factor it. You know, you get these two factors and it gives you the value x-intercepts are the x values of x equals -3 and -5. Okay? So if you can factor it, that's going to be the fastest typically. Now, the square root property. And we didn't do completing the square. That was something that's not in our curriculum. But in this case, this is where you're missing the middle term. That's where you use the square root property, is when you are missing x to the first power term. Okay, so in this case, what do? Well, here, and we don't need that sentence for what I'm talking about. Okay, here is this one, and here we would use the principle of square roots. Quadratic formula, what is it? Negative b plus or minus the square root of b squared minus 4ac over 2a. Something you must memorize. Notice I didn't say should. I said must, because not only will it be required for my test and the final without having prompts, it also will be throughout college algebra, which eventually you'll need to take. So that's one of those must remember things. And what is it? It's the fail-safe that'll work on any kind of second degree equation, quadratic equation. Whoops, that went a little fast. And any equation will work with it. It will solve problems that are prime for the sake of factoring. Okay, now we're going to practice some. We've got this equation. Well, we got to simplify that. All of this becomes that. And then we got the rest of this stuff. And they moved the 8 over to the other side. When you combine all the like terms, it ends up with this. Okay? Now, we could factor that one, or we could use the quadratic equation. Okay? That one's medium difficulty. It will factor. And here's what it'll factor into. Remember that this is also x minus 1/2. I showed you that. Okay. Then we use the zero products rule and we find the values for x. Okay, so that's just simply factoring. Okay, what about this one? Well, we put it in standard form first, and we want to solve it. Now, they're going to ask us by completing the square, and that's the absolute worst way in the world to ever solve an equation. Do not write down what's about to show up here. First place, we're not even required to do it. So I'm just going to run through it. Okay, this one, they're saying by any method. First thing they did here is they found the common denominator was 12, and they're going to multiply every term by that 12. 12 times 1 is 12, divided by 4 is 3. 12 times 1 is 12, divided by 2 is 6. And 12 divided by 3 is 4, where they did that. Okay, now we either factor or we use a quadratic formula. There it is again. In this case, they're going to use the quadratic formula. They substitute in. They start simplifying. Uh-oh. What kind of answer are we going to have? Imaginary. Okay? And we're going to have a pair of them, aren't we? Because of the plus or minus. Now, 12 will break down into 4 times 3. So that's where this 2 came from, the 4. The 3 won't break down, so it's just got to stay there. Now, I've got this thing over 6. But since I've got an I in this thing, I must use the A plus BI format. And that's not it. I have to uncommon denominatorialize this where that 6 is in both places. Now, they went ahead and divided it first, and that's okay. 6 goes into 6 once, okay, and 2 goes into 6. 2 goes into 2 once, 2 goes into 6, 3. 2 goes into this 6, 3. That's where they got that. You have to divide the same number out of all 3 of them if you're going to try that. Now, we're still not to the final answer, which is this. Now, how would I have shown going from that step up here to this step right here? Well, again, I kind of told you is you had the 6 plus or minus 2i radical 3 over 6. Again, I would take 2 goes into 2 once, 2 goes into 2, 3, 2 goes into 6, 3, and come here. Okay, then I'd have to bring that over. But either way, it'll give you the same answer. I'd almost never show that step, but that's up to you. Actually, this can still be simplified even more, because 3 will go into 3. So this thing simplifies into 1 plus or minus radical 3 over 3i. To get the A plus BI format in simplest form. Okay, what about this one? I am missing my middle term. I'm missing my x to the first term. So I use the product of square roots, where I take the square root of both sides, plus or minus. You can kind of see it there. There we go. First thing I did was I divided by 9. I would not have had to have done that since that's a perfect square, 9. Okay, I could have shown this problem this way. Square root of 9p squared equals plus or minus square root of 11. This would have given me 3p, okay? And this still would have given me plus or minus radical 11, because it won't break down. Then I can divide by 3, both sides, 3, and I get p equals plus or minus radical 11 over 3 as my answer. Well, let's go ahead and bring theirs now. Okay, now they're going to take the square root of that 9 right there, which is 3. And you see, ultimately, we get the same thing with, I think, significantly less work the other way, the way I should. Okay. Certainly less room to make mistakes. But that business only works because that 9 was a perfect square. Okay. Equations in using substitution. Okay, we have not covered this, or we did one day and very mildly. Second power, first power, no power. Same thing in a net regular ax squared plus bx plus c thing. What we can do is treat this like one number. In fact, we can even do a substitution and say, for example, u equals this parentheses okay? In which case this equation will now become u squared minus 16u minus 16u plus 39. Okay? Actually, it does. It factors pretty easily because 39 is 13 times 3 and they add together to make 16. Right? Right? 39 is 39 is 13 times 3. Okay. So this thing can factor into x minus 13, x minus 3 equals 0. Okay. And then you would get x equals 13 and x equals 3. But now we got to put this back in. Okay. Well, in this case, I need to take this 5 over that way. So 2x squared equals plus 5 plus 5, 18. Divide both sides by 2, and I get x squared equals 9. Likewise, over here, I have to do the same thing. Plus 5 plus 5. 2x squared equals 18. Oh, this should be a 3 right here. So that should, well, that 5 should still be there. So this should be an 8. Divide both sides by 2. X squared equals 4. Now, I can't leave it this because I've got to have x to the first. So I'm basically going to use property of square roots again. Take the square root of both sides. Take the square root of this. Take the square root of that, plus or minus. That gives me x there. This gives me plus or minus 3. This one, do the same thing. Plus or minus. This gives me x. That gives me plus or minus 2. Now, I have 4 potential answers. 4 potential x-intercepts. 2 squared is 4. So this is a 4th degree equation. So I could have 4. Okay. So in that case, here are our solutions. Okay. All right. Let's graph that thing. Okay, there's my graph. We'll take care of these first. Here's positive 3, there's negative 3. Here's positive 2, here's negative 2. Spread out a little bit more, maybe. Okay. Now, 4th degree equation, what are the ending values? What are the ending values on a graph for a 4th degree equation? Up and up, down and down, depending whether the first term is negative or not. Okay, that's something you guys got to know. You got to know these beginning and ending values. If it's an odd degree equation, 3, 5, 7, 9, it's going to go low to high or high to low. If it's an even powered degree equation, then it's going to be up and up or down and down. That's something you got to know. Okay, now, because of that, because this has got to be up and up, that means this one's got to go this way, that one's got to go that way. Now, there's one other thing that we could use, and it would come with some degree of pain. And we could use the y-intercept. On this problem, the y-intercept is not that number. Because when you multiply this out, you're going to get a plain number. When you multiply this out, you're going to get a plain number. And those have to be added to this. Okay? Well, how would we do it if we wanted to? That's going to be 0. That's going to be 0. So we got negative 5 squared is 25. Here we've got 25 times negative 5 is, well, actually positive 5 is 125, and 125 times 16, whatever that number is, plus 39 more. So that thing is way up there. Yes.
You get 25.
5 squared. This is 0 when you're finding the y-intercept. And here, that's 0. So you got negative 5 times negative 16, which is 80. So we got 25 times 80, whatever that is, 2,000 plus 39 more.
Why are we multiplying by 80?
Negative 16 times negative 5.
Yeah.
No, you were saying the 25.
No, oh, yeah, it
times
should
80.
be. They should be added. They should be added. The 25 here, the 80 there, should be 1 25 and 80, that's 105 plus 39.
That'd be, yeah, but it'd be a negative 25 squared. It'd be not 25 squared, it'd be a negative 25.
This one's positive 25, but this negative right here
Because you're squared.
and that would give me a positive.
Because you're squared.
Yeah.
Sorry.
So anyway, it's 144. So somewhere up here, 144 is the y-intercept. So that means this thing's going to come up and down like that, and like this, and like this. How low? Well, we just have to try between 2.5 and 3 to see how low. But that's generally what that graph's going to look like. The important thing on this, now, what if on a test you didn't go so far as to figure out this 144, and you just gave me a picture like that? You might get all 4 if you're lucky, but you'd get at least 3 as a minimum. Okay? I'm stuck to the raise, don't I? This whole problem's worked for me anyway. But you know what every 5-year-old says to his mama? I'd rather do it myself. Well, here's our substitution. They're skipping a whole bunch of steps. And got the same ultimate answer I did. Except they didn't graph it. Okay, what about this where you got fractionals? This part right here means cube root, doesn't it? 3 in the denominator means cube root. This is the power underneath the radical. That and this. This one's twice as big as that one. Just like we had before, that square on the first parentheses was twice as big as the one on the next parentheses. As long as this first term power is twice as big as the second term power, you can do that substitution trick. Okay? They took the 8 on the other side. Now, notice they left the 1/3 here. They're still a 1, and here's the 2. Okay? Now this is looking a little bit more like a regular equation fact. So we're going to do a substitution that says u equals e to the 1/3. And then we're going to work this thing kind of normally, like that. Okay, this we should be able to work out pretty easy. 4 and 2 are the numbers because that's negative. The 4 is the negative one in the factoring if you factored it. Those 2 values in turn give you that for the u's. But we're not done. We got to substitute this back in. So, yeah, everyone okay? Okay, so I've got to replace that back in. And here's how we do this. Now, we do put this in cube root form. And what they're not showing here is, well, actually, they did show it, good for them. They're showing I'm cubing both sides to get rid of that cube root. If this had been a square root, I would have squared both sides. If it had been a fifth root, I would have fifth powered both sides. Well, anyway, 3 to the 4th is 64, and that gives me feet, so that's the actual value. We're not done. We got the other half of this thing to go. Uh-oh. Look at this. Remember, you can have negative cubes.
With a cube, you wouldn't have the plus or minus either.
No, cubes you don't, odd powers you don't have plus or minus, or odd roots, I mean. Okay. Let me know when I can go forward. Yay? Okay. What about this one? Believe it or not, if this is actually x to the 1/2 power, and this is x to the 1st power, or the 2/2 power, that's got a 2:1 ratio on it. Okay. Remember me talking about it, the first term has to be twice as big a power as the second one? Actually, this one has it. Okay. Well, let's go on with their work. They're kind of doing what I'm doing, except I just went ahead and showed this as 2/2 instead of just a 1. Now they're kind of showing that as a 2/2. Okay, we can work this. They're going to do a substitution. Let u equal the square root of x. Okay, we get that. We factor it. We get the two values. Now we replace the u's with the x to the 1/2. Now, I need to go on because this is going to scroll into the next page. So let me know when I can go. Remember, x to the 1/2 is the same thing as square root of 2, or square root of. So this one's going to be pretty easy. The answer is going to be 2, right? Square root of x, square root of 4 is 2 plus r minus. Okay, we're going to have an issue with that one. We're going to get an imaginary. Well, here's that. Square root of x equals 4. Square both sides, I get 16. Why do I have to throw this one out? Because you can't get a negative square root value. So we have to discard that.
So why are we squaring?
To get rid of a square root, you square it. If I square this one, I got to square that one. Okay?
How did you get 16?
4 squared is 16. They didn't show a step here. They didn't show that. You get rid of these so they don't confuse you. Now, when you square both sides, you don't do the plus or minus. When you square root both sides, you do the plus or minus. Okay. And this one, again, we don't even have to try to finish it because you can't have a negative square root answer and get a real value. Okay. What about this equation? Twice as big as that one. Twice as big as that one, right? Okay. Believe it or not, this can be factored like that without even doing it. Without even doing the substitution, you can factor that. It factors into these two, but look at the powers. Okay. When you factor it, it cuts the powers in half. Okay. Now, these are not done. They've still got to be brought down. So you get this equation, and you get this equation. Now, what are we going to do? Well, I've kind of given you a highlight. We're going to take the square root of both sides, aren't we? Okay, and the plus or minus. I don't really know why I use that iridescent pen. It's irritating to me. What?
Square root of 1/4. Is that by dividing by 4?
4x squared minus 1 equals 0. Take that over, plus 1 plus 1. 4x squared equals 1. Divide by 4, divide by 4. X squared equals 1/4. Now, I wouldn't have had to have done this. I could have stopped at this line right here and taken the square root of that and taken the square root of that. Okay. I could have, and I would have gotten 2x. And over here, I would have gotten plus or minus 1. Which then I would divide by 2, divide by 2. And I get x equals plus or minus 1/2. Well, square root of 1/4 is 1/2. Plus or minus. So I could have done it this way just as easily. On this problem, because that's a perfect square. If that weren't a perfect square, then you couldn't do it this way. Okay? Can I go on? Okay. That side, not so pretty. We got a negative. We take the square root of that, we get a negative there. So we have to pull out the imaginary. The 2 won't break down. So we got plus or minus I radical 2 or radical 2i. What would this graph look like? Well, we've got real roots of plus or minus 1/2. Real roots. Okay. We got a pair of imaginary roots. Because this is a 4th degree equation, I know it's got to go like that. I also know that the y-intercept is -2. Whoops, probably here to be somewhat the scale. So what this thing is going to do is this thing is going to come down here, up like that, and then like that. And right here, this loop right here is where those imaginaries come from. This loop that never crosses the x-axis. That's where those imaginaries come from.
How do you know how far to go down to do that?
Okay, this is a half, right? And solve that equation, substituting this for x, and see what y values you get. And that would give you approximately how low these go. Okay? You understand the concept even though I'm not working it? Okay. Now, why did I choose -1/4 and +1/4? Because that's halfway between half and 0.
Oh, okay.
And these are semi-symmetric. Okay? Not perfectly so when they're like that, but they are semi-symmetric. So you can get at least a pretty good idea about it that way. Now, in this class, you're really not going to have to be that precise on that. College algebra, a little bit more so. But you also have a calculator for it. And remind me the last week to talk to you about calculators for college algebra class, because they're not all created alike, and there's one particular series of calculators that are absolutely the best for this class, for the college algebra class, as WSU teaches. And it's really inexpensive. What?
How do you go into fourth equation?
That 4 right there.
Are all?
The highest power tells you what the degree of the equation is.
Okay. So not all quadratics are fourth degree.
This isn't a quadratic. A quadratic is second degree. This is similar to a quadratic. It can be factored like a quadratic,
Okay.
but it's not a quadratic, it's a fourth degree equation. A quadratic is a special word that means second degree equation. Okay,
So the highest exponent is compared that it is up.
yeah, if you look at this highest exponent, that'll tell you whether it goes this way and this or this way. If that were a -4, it'd be like this. +4 is up. Positive positively holds water, negative negatively holds water. Just like when we were doing lines, if you have a positive slope, it goes up from left to right. If you have a negative slope, it goes down left to right. Well, if that had been a cube, then this thing would go in kind of a S sort of a shape from low to high, left to right. What? Well, we will have some sideways ones. This equation, the formula is y equals x cubed. Okay. You asked about sideways. Okay. If this thing went this way, okay.
Is it not just like a group? Is that
What?
Is that what you're saying? Yeah. You know how like you're saying like build a cup up, why doesn't it just make it? Like just a.
Well, because this is an odd degree.
No, but why does it go back up? Because we just talked about the
Here.
up, yeah. Does it
Left
go
to
up and
right.
down?
Low to high is the rule for just regular exponents of 3rd degree, 5th degree, 7th degree. A 5th degree one might look more like this with an extra bump in it. 1, 2, 3. In that case, you could even have another one beyond that. You could even have 4, 5. 1, 2, 3, 4, 5 if it were a 5th degree equation. But the rule about low to high for odds still works. Now, if this were a 5th degree here, then this thing's going to start looking like a sine wave. You know, the pattern that if you pluck a guitar string, you like my sound effects? Okay. Hopefully that makes a little bit of sense. We are getting pretty deeply into college algebra right this minute. Okay. By the way, that square root, that x cubed and that cube root of x are inverses. And we're going to talk about inverses next Monday. Okay, here we go. You got a rational one. I know how much you guys love rational stuff. Okay. Well, what do we got to do? We got to find the common denominator. There it is. I already found it for you. So we're going to multiply all 3 terms by both pieces of that. Now, this one, they're going to have to distribute it, which when you distribute it, it's going to look like this. You're going to take these 2 times that first term. You're going to take these 2 times that second term, and they don't show it on here, but you got to take these 2 times that 1. Okay. I wouldn't bother with showing this line. I really wouldn't. I never do it myself. I say I got this, there's my common denominator. I'm going to take it times this first term. I'm going to take it times this second term and the third term, or however many terms there might be. I can do some canceling then after I do that. These 2 will cancel. Leaves me a 1 here. These 2 will cancel. Leaves me a 1 there. And technically I have an over 1 here. That's kind of hidden, but it's there. Okay, now, since I've got all of the denominators are 1s, they go away. Okay, so this thing, there's the rest of it. Here's the equation. After you got this 3y times the y minus 1. You got this minus 2 times the y plus 2. Then you got those 2 right there. Now, let me know when I can move forward. Okay. Well, in this case, I've got that. I distribute this 3, I distribute that -2. I multiply out those 2, which gives me that business. Okay. And then I combine like terms and get them all on one side. I combine these like terms and get everything on one side. Now, here is something I can either factor or use the quadratic formula on. In this case, what they did first is they see that 2 is a factor of everything, so they divided 2 out of everything. Since 2 is in everything. Which leaves this, which is much nicer. That we cannot factor. There isn't any way you can get a 3 out of 1 times 1. So what's our option? Quadratic.
Or you need one. Where do you get the 2y? Would that not be 4y squared?
Where?
The 3y squared on one side and y squared on the other side? You subtract
Y squared subtracted from 3y squared is 2y squared. That's okay. Now can I go on? Okay. Okay, so I got that thing, I put it into the quadratic formula, simplifies down. What kind of an answer am I going to get? Pair of irrational numbers, because this thing isn't going to break down. It can be graphed, but it's ugly. Now, do I know what the square root of 13 is in my head if I had to graph this thing? No, but you know what? There's a way that I can get pretty close in my head. I'll show you. This thing right here. Square root of 16 is 4. The next perfect square is square root of 9 is 3. Right? 10, 11, 12, 13. There's 4 between them. So halfway between them would be just about a 3.5. For the sake of graphing, a 3.5 is approximately 3.5. For the sake of graphing, that's good enough. That's close enough, because we can't get any accurate of even the tenths to tell the truth. Okay? But anyway, that's called interpolation, by the way. And that might be a useful trick to you next semester, to be able to do that in your head. Okay? Well, anyway, this further breaks down into that and that. Here's the plus side, and here's the minus side of that. Okay, that further simplifies. Actually, it doesn't further simplify. Now, we don't have the uncommon denominator in this one because there's no I in. So that's technically the answer. Now, what would these two be equal to? 3 plus 3.5 divided by 2, which is 6.5 divided by 2, which would be about 3 1/4. Right? So that would graph at about 3 1/4. Now, 3 minus 3.5 would give me a negative 0.5 over 2, which would give me something uglier. A negative very small fraction. Okay, what? Uh-oh, should I have not erased that?
No, I got that. I'm just making sure it's not too anything.
For right now, the answer is no. You can leave it like this. If you had to graph this, that's when I'm saying you would need to get 3 1/2 out of this and this to be able to come up with the 2 points to graph. Okay. If you had to graph. And in this course, they're not going to do that to you, at least not on a problem as difficult as that one. Okay. You've seen this format before, right? This format is also a different form for quadratic equations. Okay. This is called the Vertex form. So if you write this down, I would write the word Vertex form. Up here, you know, this is just, if you got a square, you're missing the middle term. Up here, this is just another one of them. These are all different forms that you can have quadratic equations in addition to the standard ax squared plus bx plus c. These are just different ways that they can be shaped. Okay, again, there's the standard. We know that it's a parabola. Okay, we know that if the first term is a positive, it opens upwards. If the first term is a negative, it opens downwards. We also know that the number on the end represents the y-intercept. Okay, in standard form. Now, this pink line right here is what we call the line of symmetry. And from standard form, we're going to use this equation right here. There is a formula to find the line of symmetry. I've talked this to you about this to you one night, I think. Nope, not the discriminant. I'm going to put this quadratic formula here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Do you agree that this is true?
Yes.
Yes, it's the same thing, except I just uncommon denominatoralized, right? Okay. That's the formula for finding the line of symmetry. What the quadratic formula really does is it gives you the line of symmetry, and this tells you the spacing, how far left and right from that line of symmetry. That's what the quadratic formula really, really does. Okay? And I bet you've never heard that before. And I bet you probably won't hear it again, because not very many people tell you that. But it is. Now, the reason that I say that is to find this line of symmetry. If you know the quadratic formula, you know how to get the line of symmetry. Okay? Let's take that formula and put this equation in it and see if we get x equals -2. If we don't, then we got a problem. So x equals a is 1, b is 4. So -4 1 over 2 times a, which is 1. Okay, which equals -2. X equals -2. Line of symmetry. Okay. Now, once you've got this line of symmetry equation, that also gives you something else very useful for graphing. What that also gives you is the x value of the vertex. Okay, that makes sense, that the line of symmetry would be at the highest or the lowest point, depending on which direction the graph went.
Find the actual.
You don't look sure. No, Zoe.
How do you know when the double ends?
I'm about to tell you that. I'm one step away from there.
That's why you asked the question.
Now, I told you, -2, how far it is from the y-axis, left or right. Okay? Now we need to know, okay? So let's do that. I take this value and I substitute it into that equation. Now, technically, that would be written this way: x squared minus 4x minus 5. And when I substitute that, I would have -2 squared minus 4 times -2 minus 5. Everyone following me?
Yeah.
I'm just substituting that -2 in, aren't I? Okay, well, -2 squared is 4. -2 times +4, or times -4 is +8, minus 5. So I got 12 minus 5 is 7. Okay. Well, I already got the -2 part of this vertex right here. Okay.
Hold on.
Okay.
That should have been x squared plus 4x, not minus, right?
Oh, duh. Yes. So that's a plus, that's a plus. This is a minus 8. Yeah, okay. So 4 minus 8 is -4 minus 5 is -9. Okay. I would have figured that out from the graph sooner or later. And there's my vertex, or my turning point, if you please, or my minimum, if you please. All interchangeable words in this problem. Okay? So how do you find the vertex of a quadratic? First, you find the line of symmetry. You take that value and substitute it in to get the y value that goes with it. Okay? Now we know how to get 4 points on any quadratic. 2 for the x values, 1 for the y-intercept, 1 for the vertex, and we pretty much got that sucker nailed. Look at this. The distance from here to here is the same as the distance from here to here. The distance from here to here is the same as the distance from here to here. The distance here and the distance here are the same. That's what line of symmetry means. Okay? So if you know a point over here, like this y-intercept, then add that same amount of difference here to there, and you got that point. Okay? So that's kind of the way this stuff works. Now, they're going to have some fancy notation that's going to scare the crap out of you. I mean, scare you. Well, here's another problem. Let me get rid of my chicken scratches. Okay, this case, different equation, negative first term. So it goes down and down. Okay? Now, y-intercept. Y is 1. Right here. The point 0, 1 is the y-intercept. This gives me that. Now, I can factor this thing and I'll get these 2 points. If I want to find the line of symmetry, then I've got x equals negative b over 2a. So I substitute these values. B is 2, so I've got negative 2 over 2 times negative 1. Negative, negative is going to cancel 2 into 2, so this answer is 1. Okay, well, look at this point right here. 1, x is 1 right there. Now, how do I find the y value? Substitute 1 into this. Negative 1 squared plus 2 times 1 plus that 1. This gives me 1 plus 2 plus 1 gives me what?
1 plus 2 plus 1.
Negative, oh, this negative is outside. That negative is not affected by that square. So these 2 cancel out and the answer is 2. So this gives me the point 1, 2. There's my vertex. Here's my y-intercept, the point 0, 1. If this one's here, then that one's got to be there. Okay? And if this one's here, that one's got to be that far over. And those are going to be kind of nasty fractional answers there. Okay? This looks like about 1 1/8 maybe. Something like that, just looking at the graph. Okay, so anyway, that's the way this system works. Okay? Now then, I need to jump ahead because I'm actually not doing that bad on time tonight for what I want to get covered. No promises, but we might actually get out of here a minute or 3 early.
Watch out.
Well, that's better than late. Okay, here it talks about axis to symmetry, passes through the vertex. Okay, graph these functions f, g, and h on the same coordinate system. Okay, I don't remember whether I've taught you about this one. Have I taught you about transformations, how you slide left, right, up, down? Okay, well, this one's pretty easy, right? Starts here, goes up like that. This happens to be the point 1, 1 and negative 1, 1. Okay, if you made an XY table of that, you could get it or whatever. Okay. Now, this one. If you have an external number with your power, with your variable, an external number, not in parentheses with it. Internal number would be this. Okay. If you have an external, then what that does is it shifts it up or down one place according to the sign. So this graph it goes up like that. Okay. This graph is going to go down 2. One, 2. So it's going to go up like this and up like this. Okay? If it is an external number to the variable, it moves it up or down that many places according to sign. Yes.
Okay, so for the last one, you don't go down 2 from.
I go down 2 from compared to this one.
Does he have the same question?
See, this part and that part are the same,
Oh, okay.
except this one moves down 2. This just changes your y-intercept from 0 to -2.
Oh, okay, now it makes sense.
This one changes the y-intercept from 0 to +1.
Okay.
Now, I'm not going to go into this very much right now, but if I had x minus 1 squared plus 1. Okay? Now, here's just the y equals x squared graph, right? Plus 0. Okay? Obviously, this thing's going to move up or down one place. But this, when it's with the variable, contained with the variable, whether it's under a radical, whether it's in a parentheses, whether it's in an absolute values, if it's contained with the variable, then this shifts it left or right, opposite of sign. Opposite of sign. It's because of that. Remember when we had x2 minus x1 business and y2 minus y1 business? Yeah, well, it's tied in with that. Okay, opposite of sign. So this would move it one place left. And this would move it one place up at the same time. So this equation, once move this point one place to the left, okay, and I also move this one place up. So this equation will go like that. Opposite of sign. Oh, yes, it would be. Duh. Okay, my bad. One place to the right. I have no idea why I also erased the other leg of my blue. I'm glad you guys listened to me. So when I screw up, you can tell me.
I think you might be fired. We should go home.
Okay, you see what that did to this graph. Those are called transformations. You studied those in 7th and 8th grade. Slides, I just showed you 2 slides. A vertical slide and a horizontal slide. And there are different ways of determining flips this way or flips this way. Okay? And they're actually not that terribly difficult, but we're not going to get into them tonight. Well, let's see how much more I need to do. Oh, I know what else. One other thing I want to do. I'm just going to do it myself. Hopefully, all of you understand how you find, if you've got in standard form, ax squared plus bx plus c, how you find the first the line of symmetry, substitute that in and get the vertex. Do all of you understand that? Okay. One of those forms that I put up earlier looked like this. X minus 1 squared plus, we're going to use 4. Actually, I used an equation similar to this just a moment ago. I should have left the same equation up if I thought about it. Well, on this, if I tried to graph it, I'm going to move one place right, and I'm going to move 4 places up for the vertex. Okay? Compared to the standard y equal x squared, right? Look at this. Look at this. This is the point 1, 4, right? That's why they call this the vertex form of equations, because this number and this number tell you the vertex. Okay? But it's in this format. Now, what if you want to know the y-intercept? Well, you're going to let x be 0. So negative 1 squared is positive 1, plus 4 is 5. Okay, so that means this thing's going to go down like, whoops, that's a vertex. My bad. This thing's going to go up like this. And if that's a distance of 1 there, then there better be a distance of 1 there, and like that. So if you've got this format, this opposite of sine, and that give you the vertex. Let this be 0 and figure out what you got. We'll give you the y-intercept. And guess what? This one's going to have imaginary x values because it never touches the x-axis. Okay? Now, if we wanted to, we could square this. X squared minus 2x plus 1 plus 4. X squared minus 2x plus 5 equals 0. That won't factor. You put it in the quadratic formula, and you're going to get a pair of odds. Okay? Anyway, that's how you change from this form to that form also. Okay. And we've covered everything for tonight, though. Before I change my mind and go on.
You don't get imaginary J 0. You're squeezing yourself.
Yeah, exactly. Same result.